Let's understand why is Earth uneven in this video by seeing how forces inside Earth and on its surface make mountains, plains and valleys. Have you noticed flat fields near tall hills? Today we ask why some places are high and others low, from your school to nearby hills. Two types of forces shape land, internal ones and surface ones. We call them endogenic and exogenic forces. Simple words explained soon. Exogenic forces work on the outside, like weathering, rivers, glaciers, wind and waves. They wear down high places and build up low places. When exogenic agents remove material, we call it degradation. And when they deposit material in basins over time, it is called aggradation. The long process of wearing down by erosion and related actions is called gradation. A steady reshaping of land over time and seasons. Endogenic processes come from inside Earth. They push up and bend the crust, so new mountains and uplands can keep appearing over millions of years. Because uplift from inside is uneven, surface forces never finish the job. This constant push and pull keeps Earth uneven and alive. Geomorphic processes are all actions that change Earth's shape. They include two big groups, the internal endogenic and the surface exogenic processes. Any natural element that moves material acts as an agent. Water, ice, wind, gravity, waves and currents all carry material and shape land. Gravity controls downslope movement and strongly affects erosion, transport and deposition. Without gravity and necessary gradients, many geomorphic processes would stop today. Energy inside Earth powers endogenic work, coming from radioactive decay, friction from rotation and tides, and leftover heat from when Earth formed. Internal heat is not the same everywhere, and crust strength varies. So parts move differently and the crust becomes uneven over time. Two main internal processes shape land: diastrophism, which moves and bends the crust, and volcanism, which brings molten rock upward onto the surface. Diastrophism includes any movement that lifts, pushes, or deforms the crust, changing large areas of land in many ways over time too. Orogeny makes mountains by folding and faulting. Eperogeny lifts or sinks broad areas. Earthquakes move crust suddenly, and plates slide or collide. These movements cause faults and fractures and change pressure, volume, and temperature, sometimes turning rocks into different types by metamorphism over time. Volcanic activity makes features inside and on the surface, like sills and dikes below, and lava plains, cones, and islands above too. Exogenic processes work at or above the surface and include weathering, mass wasting, erosion, transport, deposition, and overall denudation of land too. Solar energy drives most surface processes by powering winds and the water cycle, while uplift gives rivers and slopes extra energy to work. Stress on rocks from weight, pressure, or flowing water can crack or break them, and chemical reactions can dissolve minerals too often. Different rock types and rock structures resist weathering and erosion differently. So hard and soft layers shape unique landforms and patterns today. Weathering happens on the spot without moving material. It breaks rocks by mechanical and chemical actions, and climate, rock type, and time matter. Chemical weathering changes minerals. Water, oxygen, and carbon dioxide make acids and solutions that turn solid minerals into soluble forms more easily. For example, calcite in limestone reacts with carbon dioxide and water and becomes bicarbonate, which dissolves and moves in river water easily. Physical weathering breaks rock without chemical change by freeze and thaw, hot and cold cycles, salt crystals, and pressure release causing cracks. Exfoliation peels outer curved sheets of rock, making smooth rounded surfaces, dome shapes on granite, and isolated rocky tors as landforms commonly. Plants, roots, and burrowing animals help break rock mechanically, and their decay makes acids that speed chemical weathering. Humans speed it more. Weathering makes regolith, a layer of loose, broken rock that is the raw material for soil, helping plants grow and farming succeed. By loosening and breaking rocks, weathering supplies material for rivers, wind, and glaciers to carry, and concentrates useful minerals near the surface. Weathering is the base for long-term landscape change and for soils that support ecosystems. So it shapes places where people and plants live. So what do we learn from this? The land stays uneven because inside forces lift and change crust, while outside forces wear and fill it constantly. Let us quickly remember. Internal endogenic forces build and lift, exogenic surface forces weather, erode and deposit, and gravity helps move material downhill. So today we learned the names and examples: diastrophism, volcanism, weathering, erosion, deposition. Keep curious and notice these processes around your town. Keep exploring gently, don't rush. If you want more clear notes and videos, check EduRev to practice and deepen your understanding.